Okay, and good morning. We're going to work on unit conversion again. I decided on a different way to teach it rather than what I taught on Friday, and I think it's a better way. So let's talk about that first. Here's how I would do it now. If I have a picture that says 3 yards, but I don't need yards, I need feet, okay? And we'll talk in a minute about an actual problem that tells us why we need feet. But for right now, we're just going to convert 3 yards to how many feet, okay? Now, I realize on Friday I was a little vague, and so we're going to have some analytical steps that you can count on to do this. So what you need to do is take your piece of paper with the, hi, with the units on it. Yes, ma'am?
I don't think I have that.
You think you don't have it? That's what she needs.
I was asked today.
That's okay. Here you go. This is the one we're talking about, and we're talking about the top part. Okay, so the steps I want you to go through is, if you don't have this memorized, the relationship between yards and feet, then I want you to go to your paper at the top part and look across there. Now there's yards in there and there's feet in there, but I want you to find the place where yards and feet are on the same line. Okay, yards and feet. Did you find it? Okay, Rebecca, would you tell me what it says?
3 feet equals 1 yard.
3 feet, now this is how we're going to do it, equals 1 yard. Okay, now this came off of the chart that we're looking at, so we know that this is true. This is the truth. And so what we're going to do now is use the truth to find the answer that we're looking for, okay? This is how it works. Underneath this and underneath this, we're going to make a fraction out of this, okay? Just make a fraction. Now, we're going to look up here at our problem, and we're going to put whatever the feet are under the feet, whatever the yards are underneath the yards, okay? So the top part is the truth that we know. The bottom part is going to be what we're trying to find out. So 3 will go underneath yards, 3 yards, for a while till you get used to it. Go ahead and write the actual unit. Later, we don't have to do that, but this will make sure that the yards are underneath the yards. Since we don't know the feet, this is an unknown right now, then we're going to use a variable to represent our unknown. Do y'all see? So the top part is what we do know. This is the truth. This is what we're trying to find out. Now, I will tell you ahead of time, and I will be telling you later on, but 1 fraction equal to 1 fraction, which is what we have here, is called a proportion. So you might want to go ahead and write that down in your notes somewhere, that the definition, here's how you spell it. A proportion, the definition of proportion is 1 fraction equal to 1 fraction. If there's any extra stuff, it's not a proportion anymore. The reason that this is so important is because you're going to be using proportions a lot later. And so this is a really good introduction to proportions, okay? Now, there is something that's true for every proportion ever, and it's so cool. If you have 1 fraction equal to 1 fraction, then we know for an absolute fact, this is a math fact, that if you multiply this times this across the equal sign, it will always, the answer will always, always, always equal this if you multiply across. Okay? So let's do this and show you what I'm talking about. If you multiply the 1 times x, you have 1x, and it will always be equal to 3 times 3, which is 9. And we know that 1x is the same as x. So our unknown, which was x here, is going to be 9. So 3 yards is going to equal 9 feet. Did y'all see?
Yeah, I seen it when you were writing it out. I was like, okay, I know what she's doing.
I think this is a lot easier. We're going to practice some more.
So if you multiply across, then the answer will be the same.
If you multiply across and what?
You said if you multiply across, then the answer will be the same.
Yes, yes. If you multiply this way and get an answer, it will always be the same as if you multiply across here and get an answer. Both of them are the same. Now, I guess I'll go ahead and show you the shortcut that I showed Rebecca. Okay? This is true, and you're going to need to use this some places down the road. However, there is a shortcut to proportions. Okay, are you ready? If I'm trying to find x, then I can multiply these two and get 9. Let's do this. Multiply the ones that are opposite the x, okay? Multiply those and get 9. And then divide by the leftover. See, you multiply these, then you divide by the leftover, which is the same thing that you just did. So if you want to find x, you multiply by the numbers that don't include the x, and then divide by what's left over. So 9 divided by 1 is going to be 9. Same thing. So whichever way you want to do this is fine. This is for your unit conversion. We're going to practice a few of them. And then what we're going to do is look at one of those sheets that we had to find area, but we needed to find a side first because we had, like, there were problems where one side was feet and one side was yards, and we have to convert. And so we're going to do those. Rebecca, do you mind pulling that out, that page, one of those pages with the conversion, so I can be ready to put some examples up here? All right, let's do another one of these. I need you to practice just a little bit, and then we'll go to an area problem.
You want an area of triangle?
The area of triangles, and there's one, the area of rectangles.
Okay,
Irene, you need to. You're such a joker, you little turkey. Okay.
I'm just asking you which one you want.
Oh, the area triangle.
Either the triangles or the rectangles, either one, okay? Or both, I don't care. If you have the rectangle one also. Where we had to change, there it is, that's it. Okay, what number now? Nothing yet, I'm going to.
Oh, you just have to.
Okay, let's do 144 inches equals how many yards, okay? Okay, so the first step when we have to convert is to look at your sheet and find the line that has both inches and yards in it and tell me what it says.
36 inches equals 1 yard.
I didn't hear the first part. Was it 36 inches? Yes. Okay. So she looked at her chart and she found out that the truth is that 36 inches will always equal 1 yard. Okay? This is the truth part. Underneath, we're going to put what we want to find out. And so we have 144. We have to put the inches with the inches or you'll get the wrong answer. So we're going to put the inches with the inches, And since we don't know the yards, then that's X. That's going to be our X. So now, what is this? 1 fraction equal to 1 fraction. What's that called? Proportion. That is exactly right. Okay, let's go ahead and use the shortcut because I know you like it. Okay, so here is the X, and that's what we're trying to find. So we multiply across that doesn't involve the X. Do you see what I'm saying? So we're going to multiply here, and we get 144. And then we divide by what's left, divided by 36. Okay? And so use your calculators and take 144 divided by 36 and find out what that is. I heard somebody. 4. That's exactly right. And so X is going to equal 4. Since it's in the yards column, it's 4 yards, which means it's in the yards. This is our X. So 144 inches equals 4 yards. Do y'all see? Okay.
That's a lot easier.
It is better, isn't it? Because it's more analytical. It's steps you can count on. It's understandable.
So would this also work on the paper that I had, that you had?
The one that I got from you is we didn't have to convert any units.
Okay.
And so that's going to be a different deal. Okay, since we're converting units, now we're going to use some of these problems that you have on your worksheets. And it looks like she's numbered this worksheet. Uh-oh. Okay, it's the one that says area of a rectangle if you want to pull it out. Area of a rectangle. This is the one that we're working on right now, area of a rectangle. Let's see. Okay, area of a rectangle, and it's the one up at the top, it says T2S1, T2S1, and it's the one that says, that has different units. The first one is the length, 156.
How about a T1S1?
T2S1. This is in that group
Okay.
a long time ago.
Yeah.
Don't worry if you don't have it, just write this down. I'm going to give the problem on here because the people on the Zoom don't have it anyway. All right? So don't worry about it right now, but if you want to, that's the sheet we're using. Okay, now you're going to have problems like this where you have to use unit conversion, and you're going to have to be observant. Okay, you're going to have to be careful to look at the problem instead of just multiplying a couple of numbers together. You've got to make sure that your units are the same. So here we go. We have a rectangle. And remember, you don't have to be an artist. And it says the length is 156 inches. And the width is 9 feet. Now, if you'll get in the practice of circling your units to make sure, you can see that the units are different, and you cannot find the answer until the units are the same. So we know we're going to have to convert. Now, are we going to change everything to inches, or are we going to change everything to feet? And the way that we have decided to find that is down at the bottom, it's saying area equals, and then it says feet squared. Okay? It tells us feet squared. And so we know that we want everything to be in feet because that's what they want the answer to be in. So this one is okay. This one we're going to have to convert to feet. Do you see the similarity here to what we just did? Okay, so you're going to look on your conversion chart and find the line that has inches and feet on it together, the relationship between inches and feet. So tell me what that is.
Twelve inches equals 1 foot.
12 inches equals 1 foot. Okay, this is our truth because we found it on the conversion chart, blah, blah, blah. Okay, and now we're going to put our question underneath it. Now remember, this one's okay. This one is the one we're using. So the more things you write out for yourself, the better. This is X right here. So we have to put this in the inches column, whether the inches are here or here. That's where you put it. So 156 inches. And then we don't know the feet. Okay? Since we're trying to find X, you're going to multiply here. You multiply across that doesn't involve the X. So I have 156 divided by the leftover. And what do you get? 13. Okay. And so now you have that the length is 13 feet. When we have the dimensions that are the same, we're not going to use this. I would suggest marking it out so your eyes don't go and accidentally use that in the problem. Okay, after all the work you've done, then you use the wrong number. Not cool. So now they want the area, and the area of a rectangle is length times width. So the area of this rectangle is 13 times 9, which is 117, is it? Yeah. So the area equals 117, and we're working with feet. We're working with area, so it's squared. Area is two-dimensional. So we've just added one extra step to finding the area. If the dimensions are different, you have to make that conversion, okay? And whatever they're wanting in the answer is how you're going to convert. Let's do one more, okay? Let's do a triangle. So 100% of you like this conversion better?
Yes.
Good. That's good to hear. Okay. I worried about y'all all weekend. Okay. Here's this one. You didn't know I think about math all weekend, did you?
I've been trying to figure out how to do it all weekend.
All right. Here's the problem, and they're wanting you to find the area of this triangle. Okay? So, what we do first of all, and I would always suggest this, is circle the units so you can make sure that the units are the same. That makes your eyes look at it, and you go, oh, they're not the same, so I can't do this problem yet. I can't take 9 times 2, can I? Because they're different units. So the next question is, so do I go feet or yards? And the answer, they're asking for yards. So go to your conversion chart and find out the one with feet and yards, because this one is the one that we're going to have to change. This one's okay. That's a check mark. This one's okay.
3 feet, 1 yard?
3 feet equal 1 yard. So that's our conversion. 3 feet equals 1 yard. Oh, sorry, 1 yard. Deborah, it's Monday. Okay, this is the truth. This is the thing that we know for sure. And now we're going to put our problem underneath. And so this is our problem right here. We need the feet underneath the feet. They have to match. And then we don't know the yards, so that's going to be X. And now we have, what's this called? A fraction equal to a fraction?
And proportion.
Proportion, that's good. It's a proportion. One fraction equal to one fraction. Okay, so the way that we solve a proportion is multiply the two sides that we do know. That gives us 9. And then divide by what's left to find the X.
3.
So we're going to divide by 3. 9 divided by 3 is 3. So now our X is 3. We don't use the feet anymore. Now we have yards and yards. That's what we have to find the area. We have to have the same dimensions. Okay, and now we have to find the area. How do you find the area of a triangle? We need a formula before we fill it in. What's the formula?
Multiplication.
Area equals, look it up.
Length and width.
That's the rectangle.
Oh, that's the rectangle.
We need
The triangle.
triangle.
A equals 1/2 or half BH, the base and the height.
That is exactly right. 1/2 base times height. And again, a reminder, when things are crammed together, this means to multiply. Okay, so now we have area equals 1/2. And the base is what?
3.
3. And the height is
2.
2. And it's the height because it's perpendicular to the base. The actual triangle is here. But we need a perpendicular distance from the top perpendicular to the base. And that's why they dotted this. They said the distance here is 2. That makes it the height. Okay? So the height is 2. The height is always perpendicular to the base. This is perpendicular. Okay, and when you multiply that out, you're going to come out with 3. 3 square yards. 3 square yards. Or yards squared. That means the same thing. How are you feeling? Is the conversion a lot better?
Yeah.
Okay, a lot better. All right, we can work on this when we go back to work to the worksheets, but there are other questions back in that packet from last week. One of them has to do with the perimeter of a polygon that has variables in it, okay? And so I'll put one of those up. It was one of those pages that when you look at it, you say, I'll do another page because this looks hard. Okay, I know you guys, don't I?
Yeah. Which one was it?
It's the one that you let me use, this one
All right.
that you were asking
Oh,
about.
okay.
Okay, so here is a picture. This is not a regular polygon because regular means all the sides are equal. Well, it's not my art. They really aren't equal. It says polygon unknown sides, and it says sheet 1. Okay. If this has 1, 2, 3, 4, 5 sides, what is this? 5 sides, a polygon with 5 sides?
Yes.
What's it called?
That's,
5 sides.
I want to say hexagon.
There is a building in our capital, Penta. Penta means 5, Pentagon. 5 sides. They don't have to be equal. The only way we would know that they're equal is if they said regular pentagon, a regular pentagon. Okay, here's this. It says -1 plus x yards. This is E. I'll explain these letters too, because this is the first time you all have seen some of these letters. I'm only circling them because they may get mixed up with the numbers. And this is F. B, C, D, E, F. Okay. So DE is this, and then we have X yards, and this one is 2X yards. This one is 8 yards, and this side is 6 yards. Okay, and they want the perimeter. They tell you in the problem that the perimeter is 37 yards. Okay, so they've already told you that when they added up all the sides, which is how we find the perimeter is 37 yards. And so what we're supposed to do is find the value of X and then find all the sides, the length of the sides, okay? So we're supposed to do both of those. Okay, how do you find the perimeter? How do you find the perimeter?
By adding them.
You add all the sides together, right? So let's do that. Here we go. You can start anywhere you want to. I start up here and I usually go, I'm a victim of habit. So wherever I start, I go clockwise. Does not matter. Plus, okay, I did 8 plus 2X plus X plus -1 plus X plus 6. Now, when you add all the sides together, you told me you get the perimeter, right?
Yeah.
And the perimeter, they told us, equals 37. So now we have a simple equation, and this is why I taught you how to do equations a long time ago.
That was it?
Well, it's not through,
Okay,
but
I was gonna say.
this is the hard part. It's the way that you set it up. Now, we draw a line down through the equal sign, right? And then we circle our variables, just like we've always been doing, right?
Yeah.
Okay, so up until now, we've only had one X over here, or we've had some X's here and X's there. But on this problem, notice, here's the division line, one side and the other side. All of the X's are on the same side. So you don't have to get rid of any of them. You just group them up together. So here are 2 X's. Remember, this is 1 X. Remember, this is 1 X. And so now I have 2, 3, 4 X's on this side. I'm just going to group them together so it looks easier. Now I've taken care of the X's. And now I have a bunch of numbers, just plain numbers to get together. And they're all on the same side, so I'm just going to group them up again. So here is a +8 because the sign out here, if it doesn't show, it's positive. Here's a -1, and here, or a -1, and here's a 6. So 8 minus 1 is 7, 7 plus 6. It looks a lot better than being strung out, doesn't it?
Yes.
A lot better. Okay, and that equals 37. Now the reason we added those up is because they're all on the same side, so you don't have to move stuff. Now you have a very simple equation now that you guys know how to do this. Here's our X, so we focus on this side. We need to get rid of the 4 and the 13. Which one goes first? The 13, since it's a +13, we have to -13, -13. And so now we have 4 X's left because this zeroes out, and we have 24. Is it still showing? Yes, barely. And then now we have to get rid of the 4. So we divide by 4, and now we find out, I'm going to come back up here, that X equals 6. Okay, this is important to us. We found out what X is now. Okay, so the first thing we had to do was find out what x is. X equals 6. So we've got that much done, but it still says to find all of the sides. Okay, all of the sides. So we're going to go back up to our picture. Go back up to the picture. And now we know that this is 8 yards. We don't have to do anything there. We know this is 6 yards. We don't have to do anything there. But here's an X right here. And so what we do is say -1 plus, now we put the value of X in here, 6 equals, so -1 plus 5, or 6 is 5 yards. Now we know what this side is, okay? And then we come to the next side and it says just X. This is X yards. We know what X is, so we plug that in. Now we've got 6 yards for this side. Up here, we have another X. This means multiply because they're crammed together. So now I have 2 times 6 equals 12 yards. And now I've found all of the sides. Now, if you want to do a quick check and find out if you did it right, then let's just take the answers we got. We got 8 plus 12 plus 6 plus 5 plus 6. Find out what that's equal to. Here's 20, okay? 26 and 5 is 31 plus 6 is 37. Is that what it's supposed to be?
Yes.
Then it checks out that you did it correctly. Does this make a little more sense to y'all now? Good, good. Do you need to see another one or you understand it now?
Do one more.
One more?
Yes.
Okay. I'll draw it up here and then I'll let you have your paper back, Rachel.
Okay.
That might help, right?
Yeah, I was drawing sheep, so
Okay. I appreciate you letting me use it. I could hunt mine up, but
it's okay.
okay. Let's do this and this, and it kind of goes like that, and it comes down like this, and does like this. Okay. And this is 1 plus X inches. And no, it's not. It's not. Sorry, looked at the wrong problem. 2X plus 2. 2X plus 2, and it's feet. My apologies, guys. Okay. And this one, -X plus 37 feet. And 13 feet. And 5 plus X feet. And they tell us that the perimeter equals 79 feet. Okay, this is number 5. Okay, number 5. Okay, all right. Okay, so how are we going to set this up? Somebody tell me.
Add them.
Okay, I'm going to add them up. Let's start with 13. Plus, and I'm going to go here, 5 plus X plus 2X plus 2 plus a -X plus 37, and I think I'm there because I've already done 13. 79 equals 79 because that's the perimeter. Okay? Line down through the equal sign. Circle the variables. Need the signs with it, yeah. Okay. So All the variables are on the same side, so all I have to do is put them together. I have one x here because the one's always invisible. I have 2 here, so that's 3 so far. But I'm going to subtract 1x. So 3 minus 1 is 2x. That's all I have on this side. I'm done with x's. Now I have to do the numbers. So I have 13 plus 5 is 18, 19, 20, and 20 plus 50 or 37 is 57 equals 79. Okay? Okay, Rachel.
All right, and then you'll circle your variable, and then you'll get rid of the 57.
Good.
All right, and then you need to take away the 2.
How?
You have to subtract it by the same number.
How is the 2 hooked to the x?
Oh, it's multiplication.
So you're going to?
Divide.
Good.
Dividing it by the same number.
So I'm going to come back up here again because I'm running out of room.
Okay.
And so
It's 1.
x is going to equal?
Let me see, to 2. Because it subtracts it.
Not subtract.
Divided
This is divide.
by,
22 divided by 2.
So it would be 11. Okay.
Okay.
All right.
11. Now, is that all we're supposed to do?
Yes.
Maybe find all the lengths of the sides too? We have to do that. So in order to find the length of the sides, we have to find out what x is first so we know what to plug in. 13 is okay. We've already got that. Up here, we have 5 plus, now what is x?
X is 11.
Okay. And so this side, the length of this side will become,
55. Oh, 60.
now it's plus. Now it's plus. Okay, down here, let's get this out of the way. Okay, down here, it says negative whatever x is
Negative 11.
plus 37. Do you see how we plugged it in here?
Yeah.
And so we're going to have 26 here, 26 feet. We have one more, right?
2x.
Okay, so we're going to say 2 and x is 11 plus 2. So this is 22 plus 2. So this side now is 24. Now, do we have it all?
Yes, we do.
Okay. And so we have, let's add them together. 13 plus 16 plus 24 plus 26. Did you add it? Okay. Add this up.
Oh no, my sister's calling. 79.
79. What's it supposed to add up to?
79. 79 feet.
So we probably got the right answer, didn't we? Do you get it? Okay. I'm going to switch gears now, and I want to introduce some shapes to you. Okay? Introduce. Now, these are solids. They're 3-dimensional solids. Okay? 3-dimensional solids. I'm only going to do the very basics. the very, very basics, we're going to find out what some of the names are. And that's it. We'll find out how to find surface area and volume tomorrow. Today, we're going to work on your worksheets, your back worksheets and conversions, but I want you to see the difference between here. Now, the main thing I want you to see the difference today is between prisms. These are three-dimensional now. Prism and pyramid. Both of these are 3D, three-dimensional. Okay? The difference between the two. Prism has two bases that are parallel and the same shape. This is key right here. Two bases that are parallel, they're both parallel and they're same shape. And they're named for the base. I'll draw some pictures in a little bit, but you can have a rectangular prism, which means the base is a rectangle, or you can have a triangular prism, which means both of the bases are triangles, okay? You can have a hexagonal prism, which means the two parallel bases are hexagons, and so on and so on and so on. Prisms have two bases. This is a big deal. Two bases that are parallel and the same shape, and you'll know what the bases are by their name. Everybody good? The major difference between a prism and a pyramid is that the pyramid has one base. And I don't know how to say the rest, comes to a point. I'll just say at the top, it's not very mathematically words, but it has one base. A pyramid has one base, and then the shape comes to a point. I'll just say at the top. It's going to be easier to draw the picture so that you understand. It's also named for the base. Well, different. It's also named for the base. So you can have a rectangular pyramid where the base is a rectangle. You can have a triangular pyramid where the base is a triangle, blah, 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 blah. Y'all see? Now, let me try to draw. Do you have this written down?
I'm writing it down.
I could draw a little tiny prism, or I can draw a big one. Big one would be better. So I'll wait. Tell me, Rachel.
Okay.
Or you can take a picture of the screen, whichever one you want.
It's okay. I got it written down.
Okay. It's all done, or
Yeah.
do you need some more?
No, I'm just writing down the name of the base.
That's fine.
All right, you go ahead.
Okay. Okay, so a prism, the most familiar you're going to see will be something like this. This is a rectangular prism. Different. I went blank. There we go. There we go. Okay. This is called a rectangular prism. Okay. Now, rectangular prism, the bases could be anywhere because everything is rectangular. So actually, on this one, for you guys that are starters, this, you see the bottom, here's the base, but here's also a base. Y'all see it? These are the bases. Notice that they're the same shape. They're parallel to each other, okay? Parallel to each other. And then the line that joins the two bases is going to be called the height, okay? That's going to be the height because in a rectangular prism, it's going to be perpendicular to the base, okay? So let me see if I could do this. Y'all get the idea?
Yeah.
Okay, here are the bases. Here's a triangle. Here's a triangle at the top. Okay, they should be both the same shape if I was an artist. Okay, same shape, parallel to each other. Okay, so this is a prism because it has two parallel bases, right? What kind of prism is this?
3D. 2D.
Right, it's 3D, but all of these shapes are triangular because it's named for its base. Triangular prism. Y'all see? Okay, this is what prisms look like. I'm going to leave this for a minute because I'm going to add one little piece to this after I draw a pyramid.
Do you have any pictures of those?
Here's the rectangular prism right here.
Oh, I see.
And yes, you will have some in your handouts, but I'm not getting too ready for handouts yet.
Okay.
But this is your rectangular prism. Notice that it has a top, and you can't see the bottom, but a top and a bottom that are the same. They're parallel to each other, two bases, and they're rectangles. So it's a rectangular prism. Y'all see? This one is a pyramid because if you could see through it, and I've got some that you can actually, I'll put them out on the table. You can actually hold them and look at them, okay? So this one is a pyramid, and if you could see the back, the bottom is a rectangle, do you see?
Mm-hmm.
But it only has one base and it comes to a point. Do y'all see it? Okay, so it's a rectangular pyramid. Do you see the difference? Okay, so you can refer to that for right now. Here is a rectangular pyramid. Let's do this. Okay, here's a rectangular pyramid because you can see that the base is a rectangle, but there's only one base. And from the base, from all of these are called vertex or vertices for plural. This is this little thing right here. Just so we can get that out of the way, it is a vertex. Plural is vertices. A bunch of vertexes, vertices. Okay, and what the reason I was doing that is from every vertex, there's a line that joins up to a point on a pyramid. So it only has one base, and then each of the vertices of the base join at one point. Get the idea between the prism and pyramid? Okay, now let me add one thing and I'm done. One thing. And we're not even finding volume today. Not anything. I just want you to see the pieces. You remember when we talked about polygons. You know, they had sides and, you know, we did a bunch of stuff with the polygons that had straight sides. And then all of a sudden I said, but what if the sides aren't straight? What if they're curved? Makes a circle, right? Well, in 3D solids, there are also solids that have curves in them instead of all straight lines. So the one that's like a prism, it still has two bases, but the bases this time are circles. I can. It's actually, I think of a Campbell's soup can when I see this. This is the same as a prism with circles as the bases. Notice that it has two bases. They're parallel to each other and they're the same shape. Okay, so they're very similar to a prism. The only reason it's not called a prism is because it's curved. Okay, and so it has another name, and that's called a cylinder. Okay, a cylinder is very similar to the prism because it has two parallel bases and they have the same size. Okay, so you can coordinate this with the prism, and then there's another one that's the very same as a pyramid. It has a base of a circle, but it comes to a point. Okay? And this one, see the one base right here? Since it's a circle, it has a different name, and it's a cone. And that one's easy to remember because if you turn it upside down, it's like an ice cream cone or snow cone. That's why they call it a cone. Okay, so this is a cone. It's like a pyramid because it has one base, and then the sides come up to a point. Okay, so a pyramid and a cone are similar. The prism and a cylinder are similar. Okay, now that's all I'm going to do about 3D today. We'll start with looking at volume formulas, so make sure tomorrow that you have your formula chart out and ready because you're going to have some papers tomorrow. Okay, but today we'll review and let you get some more work done on the packet from last week. Is everybody okay? Okay, Josh, I haven't asked you much. How are you?
I'm good.
Good. Anything new there for you? Just review?
Just understanding all of it, the prism, all that stuff, yeah.
Okay.
So
Okay.
coming
We're going to, I'm sorry, the students are making too much noise. Okay. What did you say last?
I said it was all coming back to me, all familiar and everything.
Oh, good. Good. So it's a good review, right?
Yeah.
Okay. All right. Well, that's it for today. And I'm not going to send out any papers today. You will have some papers finding volume tomorrow. Okay. And so I will see you on the Zoom tomorrow.
Okay.
All right. It's so nice to have you with us.
All righty.
Okay. Talk to you soon.
All righty.